So now that we have seen different types of inputs to the neural network, it's time to jump on to the what kind of format or what will be the output of a neural network. So output of a neural network, I will be discussing taking two different topologies which we have studied. So we have studied a network topology, right, in the previous sessions. That is uh, a classification problem topology and a regression problem topology. So I will be considering the similar topologies to explain the different kinds of outputs that we can expect from the neural network. So let's take the very first example or very first topology, that is classification topology. Now we have an input that is image data. So we have internally converted this image back into the numerical form, that is the pixelar form, that is converting the image into pixel and pixel to a vectorical form, right, or a matrix form, right? So once that is done, now I am feeding that into the neural network. Now my task according to the classification neural network would be like whether the input or the input image belongs to the class 0, class 1 or class 2. These classes may be anything, like whether the image particularly which I have passed, whether it is a cat, dog or a fish. So if that is the case, based on the analysis or based on the computation which happens internally in the neural network, the task of the or the output of the neural network, we would be expecting either it will be a decision or a matrix or a vector, which we can say. So vector, I specifically, because it's a column matrix, right? It's a column matrix consisting of three different values. So it on a whole, a neural network, the output would be in the form of a matrix or a vector, and the values of the matrix would be probabilities of the input belonging to the particular class. So in other ways, it will be a matrix of probabilities. So what does this probability means? So the neural network will try to judge, or it will try to identify the particular image, right? So the particular image, what will be that particular image belongs to the class 1? What would be the probability of that image belonging to the class 0? What would be the probability to belonging to the class 1, class 2, etc.? So we are the output would be generally a probability value or probable value, not accurate, like exactly 1, exactly 0, exactly 2. No, not that is the case when it comes to the neural network. It will be a distribution probability, right? So it will be a probability of what that particular image belongs to. Suppose if we have a multi-class or a multi-class identification, generally we call it as a softmax output function. A softmax output function is nothing but a multi-class logistic function, a logistic regression function, what we can say, a multi-class logistic function which is commonly used to compute that probability of an input belonging to one of the multiple classes. So we can represent that in a formula or a expression which we can sit at the top of on the output value. So a function which we have defined as a softmax output would be generally looking in this format. So as I mentioned, it would be a probability, right? It would be a probability function. So we since we have considered only three classes, so the probability would be p0, p1 and p2. So let us take the one such of the probability. So p0 equals to exponential to the power of w0 into x dash divided by exponential to the power of w0 into x dash plus exponential to the power of w1 into x dash and exponential to the power of w2 into x dash. So we can consider the input x dash as common to all the three probabilities. Since we are passing only one image at a time, we can easily say that the input remains constant, right? The input remains constant. We are passing the image of a cat at a once. So this image remains constant, but the thing is whether it belongs to class 0, 1, 2, that probabilities may be varying. So considering a particular image I have passed as cat, though that I have defined the class 0 as cat, then that particular probability function would be looking like this. So I have taken the exponential as a values because even though the weight or the weight associated with the input signal may be negative as well, but if we take an exponential of that, then that will be a positive at the end. Since the probability will be always a positive number, so this is safe to assume that we can go with this approach of finding the probabilities of a particular class output. Suppose if it is a probability function for the class 1, then the only change which we will make it over here would be exponential to the power of w1 into x dash, and the denominator remains the same. What if it is for P2? The same thing, the denominator remains constant, the numerator will become e to the power of w2 dot or into x dash. So when we combine or when we sum up all these probabilities, that is P0, P1 and P2, we should be ending up with 1, right? It should be a positive value and it should be a 1. Since we are distributing the probabilities, right? They, on a whole, we are distributing that, okay, this particular image is probably class 1, class 0 or class 2. So when we sum up the all the probabilities, it should be summing up to 1. So when we generalize this probability function as a general rule, irrespective of the number of classes, then it will be looking like pi, where I represent the probability of a particular class, then e power of wi represent the class into x dash, divided by summation of t equals to 0 to c minus 1, that is up to the number of classes, right? The number of c represent the number of classes, what we can say. So 0 to class minus 1 into e to the power of wt into x dash. So this is the same thing which we are arriving at the final form. So it's a general form of probability function when we are up to finding the individual probabilities of the softmax output function. So we'll deal with the other type of topology, right? We have other type of topology where we are ending up with a regression problem, right? So we'll deal that in the next session.